A few more examples of alcohol naming, and so I'm going to put a carbon over there, carbon over there, carbon over there, carbon over there. I'm going to place a hydroxyl functional group over there and another one over there, and I'm going to ensure that there's 4 bonds around every carbon atom, and that's in order and that's in place, and hydrogens everywhere else, right? Okay, very, very easy. Okay, so remember, whenever you're given an organic molecule and you need to name it, you need to look for the longest chain first. And so let's see, I've got 1, 2, 3, 4, there's only 4 carbon atoms, and so the longest carbon chain numbered closest to the functional groups that I see over there and over there. I'm going to number it from there, 1, 2, 3, and 4. And I'm going to say, okay, if there are 4 carbons, you know that's going to be meth, eth, prop, bute, or but, right? And between the carbons themselves, I've got single bonds, so I say butan, and I've got 2 hydroxyl functional groups. And so when you see the O bonded to H, you immediately know if that's the only functional group present, then that must be an alcohol. The homologous series we are dealing with here is the alcohol. But the functional group is the hydroxyl functional group that indicates a suffix of -ol. But now we got to be very, very careful. We can see it's -ol, but we can also see that there's 2 of them, 1 and 2. So I'm going to make that diol, right? Butan, 4 carbons, single bonds between the carbons. Hydroxyl functional group is present with -ol, and there are 2 of them, so it's diol. Okay, so that's going to be butan-1, 2-diol. Okay, right, very good. Very, very good. Very easy, as you can see. If I ask you to complete the molecular formula over here, just for practice sake, you'll tell me the molecular formula, Imaad, is there are 4 carbons. So it's going to be C4. Imaad, there's a certain number of oxygens, and that's going to be 2 oxygens. And there's 2, 4, 6, 8, 10 hydrogens. Let's just count that again. 3, 4, 5. 1, 2, 3, 4, and 5. And there we go. Right, that's the molecular formula, C4O2H5. Okay, so let's look at another example. I'm going to draw out the main chain again in red, and I'm going to go 1, 2, 3, 4, 5, 6, 7 carbon atoms. Okay, and I'm going to place an oxygen bonded to a hydrogen over there, and then I'm going to ensure that there are only 4 carbons around everything else, right? Why do I keep saying 4 carbons? I mean 4 carbon bonds, or 4 bonds around each carbon. Okay, this is why they say don't do work in the middle of the night at 1 a.m. It's not a really good idea, but if it's the only available time, we just got to use it, eh? Okay, so we need to first see if we can find the longest chain possible. So 1, 2, 3, 4, 5. No, that's not the longest chain. 1, 2, 3, 4, 5, 6. Oh my word, that's the longest chain. Now we also need to see if we need to number closest to the hydroxyl functional group. So if I start over here, I go 1, 2, 3, 4. That functional group lies in the 4th carbon. If I start on this side, it goes 1, 2, 3. Oh my word! Can you believe it? That's the side to start with, because then it's on the 3rd carbon, and that's closest to the start. So it's 1, 2, 3, 4, 5, 6. This over here is your hydroxyl functional group, and the other thing over here is going to then be a branch, right, or a side chain. This is a branch or side chain, right? And so we name it according to the longest chain. And I'm going to see, okay, the main chain over here, the longest chain has got 6 carbons. And 6 carbons, as you know, meth, eth, prop, bute, pent, hex. Okay, so hex is going to be Hex. And as you see, there are only single bonds between the carbons. so we're going to add AN. If you go to your organic chemistry summary sheet, you will find ANE if it's an alkane, or if it's any of the other molecules, you're going to say just AN. And as you can see, the hydroxyl functional group makes the name end in ol, right? And that lies on the third carbon, hexan-3-ol. Righto, are we done? Well, we've sort of accounted for the main chain. We've accounted for where the hydroxyl functional group, remember this again, is the hydroxyl functional group. And the homologous series we are dealing with is the alcohols. And that over there is going to be 1, 2, 3, 4, 5. We've left out the branch. And this branch, when you have a single carbon with 3 hydrogens around it as a side chain, we call it a methyl side chain. And that methyl side chain lies on the 4th carbon. So we'll say 4-methyl hexan-3-ol. Okay, and there you have it. Let's look at one more example, and then we'll move on to an alcohol, an alcohol exercise, right? An exercise on the alcohols. Okay, so in this example, I want you to actually work from the reverse, right? And so let's try one. It's 4,4. Ooh, what type of handwriting is that? Oh my word. We'll pray for you today. 4,4,5 dash trimethyl trimethyl hexan-1-ol. Right. 4,4,5 dash trimethyl hexan-1-ol. Let's look at this and let's critically look at it. Right. Firstly, you need to look at this thing. When you see the OL, this tells you that you're dealing with an alcohol, and if you're dealing with an alcohol, you're going to have a hydroxyl functional group present. Hydroxyl functional group. This over here tells you that there are single bonds between the carbon atoms. This over here, the hex, tells you that you're going to have 6 carbon atoms with single bonds between them, and on the first carbon atom I'll have a hydroxyl functional group. And then it also tells me that on the other side I'm going to have a methyl side chain, which is this thing over here, right? And that over there is bonded to the rest of the molecule, that thing over there. And I'm going to have 3 of these, 3 of them, and the 3 of those are going to be on the 4th carbon, the 4th carbon, and the 5th carbon. And that's why whenever you see tri, you're going to have 3 numbers before the dash in the name or the description thereof. So it's 4,4,5 dash trimethyl hexan-1 dash ol, and 4,4,5 trimethyl hexan-1-ol. Let's draw that out now. We're going to start with the main chain, draw out 6 carbons, put single bonds between the carbons, ensure that our hydroxyl functional group lies in the first carbon, and then we're going to insert our side chain. So you're always going to start with the main chain. So let me just draw that out again there. 4,4,5 dash trimethyl hexan -1 -ol. So let's start with the hex, right? Let's start with that. Okay, 6 carbons. 1, 2, 3, 4, 5, 6. Single bonds between the carbon atoms themselves. That's why it's hexan. So I've done that part. 1, 2, 3, 4, right? And then, as you know, you can only have 4 bonds around each carbon atom. Okay, 4 bonds around each carbon atom, and now let's insert our hydroxyl functional group, and I'm going to do that in black, which is this thing over here on the first carbon, and I'm just going to irrelevant which side you start from, as long as because right now everything is even. Okay, so I'm going to just start from the right hand side because I just seem comfortable with it. And I'm going to place on the first carbon oxygen bonded to hydrogen, and that's my hydroxyl functional group now. Then I'm going to say, okay, on the fourth, and again on the fourth, and on the fifth carbon, I need to place a methyl side chain, right? And that's going to be what we call a branch over there, and that branch needs to be a methyl branch. So let's put that in, and I've got methyl, which is going to be something like this. But I shouldn't only have one. I need one of them on the fourth carbon, another on the fourth carbon, like such. And then on the fifth carbon, I also need one. So I'm going to just place that one here. I'm going to bring this bond a little bit down so that I have some space to work with. Okay. And I'm going to say that's the other one over there. Right. So I've got one branch, two branch, and three branches, all of which are methyl branches. One of them is on the fourth, another is on the fourth carbon, and the other one's on the fifth. And all I now need is just a series of hydrogens, right? Okay. Righto. Okay, so from here you can work at the molecular formula. You can also work at the condensed structural formula. And I need one more hydrogen over there. And so let's write out the condensed structural formula starting from carbon 1, right? And that's going to be CH2, right? And there's also hydroxyl functional group, so I'll put it like that, CHC, and there's two hydrogens and one hydroxyl functional group, which I'll place in a bracket like such, which is then bonded to a carbon with two hydrogens, bonded to carbon, CH2, then bonded to another carbon with two hydrogens. So this one over here is carbon 1, this one over here is carbon 2. That carbon is bonded to this carbon and has two hydrogens, that's carbon 3. Carbon 4 is just a carbon, but is bonded to a methyl side chain, and each methyl side chain is carbon bonded to three hydrogens. So that's represented by CH3, and there isn't just one on that carbon, but there's two. Okay, CH3, right, and let's continue to that's just CH. I'm just going to continue, just know that this continues on over here. That's first carbon, second, third, fourth. I'm on the fifth carbon, which is just CH with a side chain of one methyl side chain, which is CH3. And then we have the last one, which is carbon bonded to three hydrogens, which would be CH3. Just remember that this is read along, and then this piece of here goes right next to that. Hey. Okay, so there's an example with a methyl side chain. We've introduced 6 carbons, single bonds between the carbons, hydroxyl functional group. This thing over here is known as the hydroxyl functional group. Okay, now remember, you are not meant to watch me do this. You are meant to do this while I do this, and you are meant to engrave the neural pattern and to adopt that. Okay, best of luck.